So in this presentation, this is a continuation of the proofs for binomial coefficients. Okay, so this is the third in our series. So I just sort of separated this out from the other two because it's a little bit longer. Okay, so what I'm going to do actually, so it's essentially n choose r plus n choose r plus 1. Okay, so we have these two values here, and what we have to do is sort of prove that the addition of this term here and this term here will give us n plus 1 over n plus 1 choose r plus 1. Okay, now just to help us, what I'm going to do is actually work on the basis of, or really work with the left hand side here. Okay, but it's actually sort of good to know what the right hand side would work out as, so give me something to aim towards. Okay, now so when I evaluate this n plus 1, I should get n plus 1 factorial over r plus 1 factorial times n minus r factorial. Now, just as a remark, what should happen in these instances is that the argument for the factorial for the first part plus the argument for the factorial for the second part should add up to this. Okay, so when you try to sort of express that out, you just might need to take a moment just to actually figure out that the term here is that you need is n minus r. How you might go about it is subtract n plus 1, calculate n plus 1 minus r plus 1, and then you get n minus r factorial. Okay, so what we're going to do here is this is the this is the left hand side now. Okay, and I have two expressions here. I have this expression here and this expression here. Okay, and what I'm going to do is actually this actually also requires a little bit of work here. Okay, sorry, this to actually evaluate it. Okay, so n factorial n over n. Sorry, let's say that again. N from n choose r plus 1. So you actually have to just take a moment here to figure out what goes where. Okay, so we on the denominator, sorry, on the numerator we would have n factorial. On the denominator, as part of the denominator, we would have r plus 1 factorial. So what goes in elsewhere, essentially what you do there is n minus r plus 1, or n, if you r plus 1 in brackets, n subtract that, you get n minus r minus 1. Okay, so this is important here. What we are going to do is we're going to try and get everything here and here in terms of r plus 1 factorial n minus r factorial. Okay, so we have the r plus 1 factorial here, that bit's okay. We have the n minus r factorial bit, that's okay. So essentially we have to work with this n minus r minus 1 factorial and r factorial over there. Okay, so I'm going to sort of work on one term at a time. Okay, so I'm actually just sort of moving from right to left. Okay, so what I'm going to do here, this is actually sort of an informed decision. So I need to work on n minus r minus 1. Okay, factorial. Okay, now the reason is I want that to be n minus r factorial. So what I'm going to do here with the second expression, and I just arbitrarily picked the second expression, is multiply above and below by n minus r. This is a fraction here, okay? So n minus r times n factorial, nothing really happens there. Essentially, the key thing that happens here, if we multiply n minus r minus 1 factorial by n minus r, we get n minus r factorial. Okay, so this expression here, n minus r minus 1 factorial times n minus r, would result in n minus r factorial. Okay, so this is this expression simplified. Okay, now we're making progress. N plus 1 factorial times n minus r factorial. That's what we want on the denominator. We're looking good so far. Okay, n factorial times n minus 1, we'll leave that for the time being. We'll just have to work on this side. Okay, so I'm on the left hand side now. Okay, and I'm going to do something similar here. So I'm starting here. Okay, and what I'm going to do is something similar here. N plus multiply above and below by r plus 1. And the reason is, if I multiply above and below by r plus 1, I get r plus 1 times r factorial, which will give me r plus 1 factorial. Okay, This sort of term over here on the this side here, we're just going to leave alone. It's sort of ready for the time being, but it's just on standby. Okay, so that's grand. So if we multiply r factorial times r plus 1, we get r plus 1 factorial. Now, the denominator, that looks good. That's what we want. That looks good. That's what we want. So we can just actually combine this into a single expression. We have it in terms of n factorial here and n factorial here. So we have n factorial times r plus 1 and n factorial times n minus r. And essentially what we're going to do is add this to this. Okay. And there we go. When we add them together, essentially it's r plus 1 plus n minus r. That actually resolves into n plus 1, okay, which is n factorial times n plus 1 is n plus 1 factorial, okay, and that will give us, that brings us back to where we need to be. That is the n plus 1, choose r plus 1, that is the answer. So we had a sort of sneak peek at this earlier on, just to sort of say this is what we needed to get to. Okay, so that's that one done. Okay.